So now there is a technique which is known as attribute agreement analysis, which is used primarily for discrete data when your Y is discrete in nature. In that particular case, we will go for a attribute agreement analysis. But when your Y is continuous, in that case, we use a tool called gauge RNR. So we'll talk about both today. So in case of a discrete data and you want to measure whatever data you have with different operators or with the standard, so there is a technique which is called attribute agreement analysis. It is also known as AAA, or it is also known as 3A. You can call it either one of them. Attribute agreement analysis is used to assess the agreement between the ratings made by appraisers and the known standards. So this is to be done when you have multiple operators and the standard, and we want to compare the readings of each one of them to come to a consensus whether my measurement system is good to go or not. What is the standard that we follow to make sure that my MSA is good to go? We talked about it yesterday as well. Does anybody remember that? I said out of 10, this number has
10%.
So let's say there are 10 transactions that I'm monitoring. Okay. Out of that, how many should be good enough when I say that my measurement system is good to go?
90%.
90%. Absolutely.
90%.
Yes. So 90% is a standard. If 10 people are measuring it, if 2 people are measuring the 10 transactions, out of 10, if they match 9 times, which is 90%, then I would say my measurement system is good to go. So, okay. So this is something which we can do with the help of attribute agreement analysis. So let's look at this example carefully. Okay. So these are 20 transactions which were to be monitored. Okay. So typically in a project, if you are a project leader, you have done some kind of a random sampling, and because you are not particularly sure about the data which you have. So what you have done is you have given it to 2 different operators. You've given it to Rohit and you've given it to Rahul as well. Okay, and you told them that I want you to measure this, whether it's a true or a false. Okay, so you see here, Rohit has given his observation for the 20 transactions. Rahul has given his reading for the 20 transaction. Then Rohit once again did the same. Okay, and then Rahul did once again. So what is the technique when the same person is measuring the same transaction again? What is the technique called as?
Repeatability.
Sorry?
Repeatability.
Repeatability. Absolutely. Absolutely. And if I'm entering more operators into it, the amount of variance, what is known as?
Reproducibility.
Reproducibility. So in this particular example, is it a repeatability or a reproducibility?
Reproducibility.
Reproducibility. More than one operator.
So it is both actually. Okay. It is both, because you see Rohit has measured and given his observation, and Rohit is doing it again.
So here it is repeatability.
Okay.
Yeah.
And now we have entered another operator, Rahul, and Rahul is also doing it again. So in this particular case, when we want to do a measurement system analysis for discrete data, for attribute agreement analysis, we have to enter repeatability as well as reproducibility. And you see there is a standard also. So we have taken the information from the standard as well, and standard has also given their rating. Now, how do I calculate MSA? So I have 1, 2, 3, 4, 5. And out of that, how many times all of them are matching? So you see, out of 20, there are 3 transactions which is not matching with the desired result. Okay. So here it's incorrect because you see it is not matching.
First one true.
Yeah. You see the 12th one also, and you see the 17th also. So which is 17 out of 20 is good, which means my MSA is at 85%. So in that particular case, I will not accept this. I would say that my measurement system is not good to go. And then I will not accept it. For me to accept the measurement system analysis, my standard has to be 90% and above. And then only I would say that my measurement system is good to go now. So in this example, if you see, it is not accurate. So this is an example where MSA will not be accepted.
So, Simranpreet, in case like this, when the MSA is not being accepted, then what normally is done? Like you go ahead and resample and do the calculations. How do you go about it then?
Thank you for asking this question. Otherwise, I would have also said it. So there are two ways to look at. So let's understand it very well. In a business process or in any side of the world, majority of the case, we have the automated reports, okay? Automated system which fetch the reports, and no matter how many times you fetch the report, you will get the same result always, okay? In that particular case, MSA is not required because it's a system generated. But in case of a manual report, wherein the report is being fetched manually and we are dependent on people, where there is a person who is part of the MIS team or part of the reporting team, he is calculating it using some formula. And therefore we don't rely on his calculation, and that's why we're doing MSA. So if the report is system generated, wherein if I want to calculate any of the metric, there is a system which fetches the report. In that particular case, MSA is not required. So if that is a scenario, you would mention that my report is system generated. You will just take the snapshot of that system where the report is being fetched and say that it is not required. But there's still 15-20% cases where it is not system generated, where MSA is required. Now coming back to the question that you asked, that if it is less than 90%, what would I do? Would I do resampling? Would I go ahead and identify? The first and foremost thing is which I need to identify is that which of these operators has an issue with the measurement system. So when we calculate MSA on Minitab, okay, we can easily identify that which of these operator has a problem. So right now, this will become a very manual sort of activity. If I ask you to analyze that out of Rohit and Rahul, which of these operators is not matching with their own readings, which they have given it first time, okay, it would become very difficult for you. And tomorrow, if you have big data set, then also it becomes very, very difficult to do it manually. So with the help of Minitab, first we can see what is my current level of MSA, whether it's 90% and above. Second, it tells me which operator has an issue for calculating MSA. So let's say if Rohit comes out to be a defaulter, then probably I would replace somebody else with Rohit and redo the MSA. Okay, and then I'll try to identify that what is the formula that Rohit is using for calculating. It seems that he's using a different formula or he's using a different technique, and therefore I would like to coach him and reassess it. Even if it's a case that he is still making an error, then we would definitely go ahead and change the operator and make it sure that the measurement system is good to go. So just look at it. Here it is quite manual. Here we are dependent on people who tell me that where I'm currently standing in terms of any of the metric, and therefore MSA is required, right? So we will do this on Minitab, okay, and then you would be able to see that what is the issue that we are facing. So I will just open Minitab and then we'll do this exercise on Minitab. Okay, so just give me a second. I will just open Minitab.